Okay, here's this next dandy of an assignment. So the last kind of graphing you have to worry about this semester. Now we've went over when we have just x's, those are linear equations. We have when we have x squared, those are parabolas. And then when I have an exponent higher than a 2, it's called a polynomial. And all that means is it's just going to go all over the place, okay? All over the place. All I can tell you, the only advice I can give for all over the place is there's no pattern to it. You just go 3, 2, 1, 0, -1, -2, -3, and then you plug and chug. Okay, so I'll put 3 in. So I'm going to replace all the x's, okay, with these following numbers. Obviously, it's going to help with a calculator, so we're going to insert 3 to the power of 3 minus parentheses 3 to the power of 2. The power of 2 is just right there. Minus 9 and then 3 plus 9. Okay, I got 0. That's not always going to be 0. Okay. Then I'll do it with 2, then I'll tell you the rest of them. So I'm going to put a 2 in, 2 in, 2 in. So I've got 2 to the power of 3 minus 2 to the power of 2 minus 9 times 2, not a power on that, and then plus 9. Okay, it gave me -5. Okay, I actually have the rest of them in front of me just so I didn't just bore you entirely. So I got 0, 9, 16, and then 15, and 0. Okay, so let's graph them. My highest number is 16, so let's go by 2. So 3 zeros right there. You don't need to label it. 2, -5, and we got to go by 2. So 2, 4, and then that's where 2, -5 is going to be. 1, 0, so 1, 0. 0, 9. So we got to go 2, 4, 6, 8, and then right there. -1, 2, 4, 6, 8, 10, 12, 14, 16. Remember, pay attention whether it's positive or negative. -2, 15, so I go left 2, 2, 4, 6, 8, 10, 12, 14, and 15. And then -3, 0. Now, here's what you do to connect them. I said it was going to be all over. So in the order you made the points, you got to connect them. It looks kind of like a snake. Okay. Now, here's what's confusing though, is how to put the arrows. First, I'm going to look for the arrow on the right. I want to decide if that's going to go up or if it's going to curve back down. What I need to look at, and listen here, this is the one I'm worried about. This one here on the right. You need to put a 1. If you don't have a number in front of your first x, put a 1. Now, is that positive 1 or negative 1? It's positive 1. That's called your leading coefficient. It's a simple question. Is that a positive 1 or a negative 1? It's a positive 1, so it's positive. Now, if that's positive, I make the thing go up. Had that been negative, I would have curved it so it went down. Okay? Now, go to the arrow on the left. The arrow on your left has to do with your highest exponent. The highest exponent is a 3. Okay, here's what I'm going to write. If the highest exponent's even, the arrows go in the same direction. If the highest exponent's odd, they go in opposite directions. So what's my highest power? My highest power is a third power. Okay? So the highest exponent's a 3. It's odd, so the arrows go in opposite ways. So that's going up. So that's going to be going down right there. Okay? Next problem. Same thing. It's a polynomial graph. That means it just goes all over the place. It almost looks like a snake. Okay? Whoever made these problems is a snake too, made us do these. 3, 2, 1, 0, negative 1, negative 2, negative 3. I'll give you a little piece of advice. When you put 0 in, it's always this right here, because everything else goes away because you're multiplying by 0, and that would give you 6. Okay, so I'll put 3 in, and again, you're just inserting those values in for your x's. It's really quite easy. So 2 and then 3 to the 4th power. Minus 3, and then we're going to put 3 in, and then to the 3rd power, plus 2, and then 3, and that's going to be to the 2nd power, minus 7, and then another 3, and then plus 6. Okay, it gives me 84. Now I'm going to tell you what the rest of them are. 8, 0, 6, 20, and 288. Now, as you know, I got this 288 that's like way out there compared to anything else. I'm not going to graph that. If I get it like a huge outlier, just don't worry about the graphing. So let's go by tens. So I go 1, 2, 3, 10, 20, 30, 40, 50, 60, 70, 80, 84. Okay, so that's 3 and 84. 2, 8, so I go 2, and then if I'm going by tens, 8 somewhere in here. You got to remember what you're going by on that y-axis. 1, 0, that's right there. 0, 6, keep in mind I'm going by tens, so it's 0 to tens between here. Negative 1, 6, I go left 1, then I'm right there. These do weird things. They follow no discernible pattern. Negative 2, 20. I go left 2 and then up 10, 20. Okay, now it kind of looks like a parabola, but not really. Okay, connect the points. Now, first thing, you're looking at the arrow right here. This is first. That is freaking first. Sorry, my language. I shouldn't be using that language on tape. Okay, that is first. Okay. So if I need to decide if that goes up or if it needs to curve and go back down. That's determined by your leading coefficient and whether it's positive or negative. So it's 2 and it's positive. So I make that go up. Now had that been negative 2, I would have curved it downwards. So that's going up. That's infinitely higher. As we get out this way, that just goes up, up, up. Now, if that would have been negative, I would have curved it and it would have gone down, down, down. Okay, now your other arrow right there. I need to decide if the highest exponent is even or if it's odd, knowing that if it's even, the two arrows go in the same direction. But if it's odd, they need to diverge in opposite directions. Looks to me like we have a 4th power making it even. So if that's going up, that'll go up as well. Okay, pretty exciting stuff. Now, here's this, pause the video and go do those 2 graphs. Okay, again, once again, that's a positive, so this arrow's going up, and that's odd, so this other arrow is going to diverge, it's going to go the opposite way. That's a positive, it's going to go up. And that's an even exponent, so this other arrow is also going to go up. Okay, now here's what I want to do. This gets us ready for the next thing. Okay, 5x times x squared minus 3, then x plus 4 times x plus 4. Now, I have this factored already. Eventually, we'll have to get to this point. Okay, it's not too hard. It's not as bad as it looks. Now, there's a lot of different answers. I have this x here, so that's 2 answers. X to the second, or 1 answer, because that is not to any power. It's one, it represents 1 solution. That is to the 2nd power, so I'll get 2 out of that. I'll get 1 out of this and 1 out of this, okay? So all I do is take 5x, set that equal to 0. X to the 2nd minus 3 equals 0. X plus 4 equals 0. X minus 4 equals 0. And it's pretty, you divide by 5. And I get 0. There's my first answer. Now here I need to add 3, but since it's a 2nd power, I need to square root. Okay, so that means we could have a plus or negative there. Now 3 is not divisible by any of the perfect squares, so I don't need to do this. I just keep it square root of 3. So that's 2 answers. So square root 3, square root 3. We just put a negative out front of the second one. Minus 4, I get negative 4. Plus 4, I get positive 4. Okay? So with those second powers, you got to remember square root. If it's a perfect square, great, write the answer. If it's not, see if it'll divide by anything up there. If not, we'll just leave it and it's square root. Okay, my next problem, we got x. By the way, this means it's to the first power, so that's one answer. To the first power, one answer. To the first power, one answer. To the second power, that's 2 answers. So I've got negative 6x could equal 0. The x minus 5 could equal 0. The x plus 5 equals 0. And the x squared plus 18 equals 0. So I'm going to divide by negative 6. I get 0. I add 5 to both sides. I get 5. I minus 5 from both sides. I get negative 5. And I got 2 more answers, and it makes sense. We got to take 18 away, so x squared equals negative 18. So we square root both sides, so x equals plus negative. Now with that negative under a square root, we extract it and bring I out. Now 18 is not a perfect square, but it does divide by a perfect square of 9, so I need to make the 2 square roots. 18 divided by 9 is 2. So that's 3. So it's 3 square root 2. Now the I needs to go right in front of the square root. So 3i square root 2 and negative 3i square root 2. Okay, next problem. F to the first power, so I'm only have one answer. That's to the first, there's only going to be one answer, and that's to the second, leaving us with 2 answers. So 2x can equal 0, x minus 5 can equal 0, x squared plus 9 can equal 0. So I'm going to divide by 2 here, giving me 0. I'm going to plus 5 to both sides here, and that gives me 5. Now, this is 2 answers. Not only do we have to subtract 9, since it's to the second power, I need to find the square root. Now, since we have a negative under there, we got to extract the I. And guys, 9's a perfect square. Just get rid of the square root of 9 and put 3. So since there's no square root, it's 3i, not I3. If you don't have a square root, you put the number there. Okay. Here's what this really means. It means this I crap. It means that this graph crosses the x-axis at 0 and 5. Don't draw this, just kind of. So if that's 0 and that's 5, whatever graph that looks like is going to cross here and here. The I means it doesn't cross anymore. That didn't make sense. It's not really that important right now as we sit here. Okay, that's to the first power. There's 2 answers from there because we have a second and then 2 answers from the other one. So my factor of 3x equals 0. My factor of x squared plus 5 equals 0. X squared minus 8 equals 0. So I'm going to be dividing by 3. I get 0. I'm going to take 5 away. X squared equals negative 5. And then we square root. We shouldn't have that negative. You got to use the I. Is 5 a perfect square? No. Does it divide by anything up there? No, other than 1. So we keep it I square root 5. So I square root 5 and I square root 5 negative in front of the whole thing. Next one, I add 8, x squared equals 8, then I square root. X is plus or negative, and this isn't a negative 8, so I is not going to be in the answer, okay, because that 8's positive. Now, is 8 a perfect square? No. Can it divide by one of the perfect squares? Yeah, it can divide by 4. Now take 8 divided by 4. It's not hard. 8 divided by 4 is 2. It should be in that order. You get rid of the first one because you know that's 2. So 2 square root 2. So you got 2 square root 2 and 2 square root 2 negative. Okay.